Okay, today's lesson is 12.4 derivatives. And yes, I did skip 12.3 because I think you'll be happier that I'm saving you a little bit of work. So the first two lessons that you dealt with limits. You first did it graphically, then you did it algebraically. Well, now we're going to talk about basically applications of those limits. And limits can be used to find the slope of a tangent line. The slope of a tangent line is also known as the instantaneous velocity of a graph at a certain point. And we're going to get more into that. But what I really want you to know is tangent lines are important. So the first thing in Delta Math I have you do for your homework is actually drawing those tangent lines. Remember, that means the line only touches the graph at one point. And you're going to need to find the slope of those tangent lines. Well, we use limits to find those. That's what this definition is right here, is to find the limit, okay, of a function as h approaches 0. And then you have f of x plus h minus f of x all over h. Okay, that is the limit. The limit is equal to this notation, f prime of x, and that is known as the derivative of f of x. It's read f prime, okay? So the next thing, after you draw some tangent lines, you actually have to evaluate the derivative or find the derivative using limits. So I want to show you what that's going to be like, and then I'm going to get into and tell you why you'll be happy that we're doing 12.4 before 12.3. So find the derivative of f of x, and this time we're doing it at any point, okay? My function is f of x equals 6x squared plus 7, and then they want you to find it at x equals 2 and x equals 5. Well, in the first activity of Delta Math that you have, you actually have to put it in just like this. So the nice thing, though, is if you read the directions, okay, this first, I probably erased it. Okay, so this right here is all that you have to do. This one, and here's another example of the same thing. Okay, so remember, it's f of x plus h minus f of x. So if my function is 6x squared plus 7, where I see an x, I got to put x plus h. And then, so that is 6x squared plus 7, and then minus, that's my f of x, all over h. That's all you have to put in. Just need to know that you understand how to use this definition with this function. So here's another example. It says negative 5x squared plus 2x minus 12. Wherever I have an x, I put parentheses, and everything else looks the same on this first part, but I put x plus h. And then in the second part, that's what f of x is. So the fact that we're doing 12.4 before 12.3 means you don't have to do all this stuff right here. So that's all you have to do on the first part. Okay? Now, the next thing that you're going to be doing is finding derivatives using rules. Okay? And the first rule that you're going to have is called the power rule, excuse me. This is your power function. Okay? If f of x equals x to the n, and n is a real number, then my power rule says that the derivative, f prime, you take the exponent and move it down front, and then you subtract 1 from the exponent. That is your power rule. So here's 3 examples I'm going to do for you. So first off, it says j of x equals x to the 4th. And so I'm going to go find j prime. I said f because it looked like an f to me. F or j, either way, you'll be fine with it. So I moved the 4 down front. I have a 4. And then I lowered my exponent by 1. 4 minus 1 is 3. Okay? Look at 2b. It says k of x equals the square root of x to the 3rd. You cannot do it like that. You have to rewrite that, and you need to use rational exponents, which we did earlier in the year. So if you remember, on a rational exponent, this index, that's the root of my radical, and the root is down on the bottom. So when I write this as a rational exponent, it becomes x to the 3/2, because there's an imaginary 2 that's on the bottom. So now when I go write k prime, I move my 3/2 in front, And then x, I have to take 3/2 minus 1, and 3/2 minus 1 is 1/2, so it's x to the 1/2. So your fraction, class calc, your calculator, however, can do these fractions for you, making that pretty easy. All right, the next one here, m of x equals 1 over x to the 5th. Again, you need to rewrite it, and to rewrite that so it's not a fraction, I make it a negative exponent. I move it up to the top, and that becomes x to the negative 5. So now when I go find the derivative of it, okay, then I'm going to move my exponent down, so that's going to be negative 5, and then I got to subtract 1. So negative 5 minus 1 is negative 6. And Delta Math might let you leave it like that. If not, then you would have to simplify it and put that exponent back down to the bottom to make it positive. So we would have negative 5 over x to the 6th. So just be aware of that and figure out which one he needs. Okay, so that's my power rule. Now, that power rule can be expanded to apply to polynomials, okay, or other functions that can be simplified to look like a polynomial. So in this particular case, f of x equals 2x to the 5th minus x to the 3rd minus 102. So f prime of x, when I move my 5 down, I have to multiply it by the 2. So 5 times 2 is 10. And then if I take 1 away from my exponent, 5 minus 1 is 4. So it's going to be x to the 4th. And then minus, move my 3 down front. And then 3 minus 1 is 2. So it's going to be x squared. And if you didn't realize it, okay, this is x to the, your constant is x to the 0. That's 102 x to the 0. So when you take the 0 down and you multiply it by the 102, it's gone. So anytime there's no x, it goes away on the next level to find the derivative. Okay, look at 3b. You don't know how to deal with it yet, okay? You have to get it to look like this. So you have to simplify this thing, and that means I got to distribute my 3x to the 4th through that parentheses. So that's going to give me 3x to the 5th plus 6x to the 4th. And now when I take the derivative, okay, 5 times 3 is 15. Subtract 1 from 5 and you have x to the 4th. 4 times 6 is 24. Subtract 1 from that exponent and you get x to the 3rd. So that is the derivative. Okay, h of x equals 4x to the 4th minus 3x squared plus 5x all over x. Again, you cannot deal with it like this. You've got to simplify it to make it look like a polynomial. Okay, so when there's just one term down here, that means I can break it up and write 4x to the 4th over x, 3x squared over x, and 5x over x. So when you simplify that, in essence, I'm going to get h of c, or h of x, excuse me, I don't know where the c came from. So x to the 4th over x is going to be 4x to the 3rd minus 3x and then plus 5, because basically I took an x out of each of those terms. And now to find the derivative of that, okay, 3 times 4 is 12. Reduce my x to the 3rd by 1 is x squared. And then at 3x, that's to the first power. And when you subtract 1 from that, x 1 minus 1 is 0, and that is equal to 1, so we don't write it. So it's just going to be minus 3. Okay? As I mentioned at the beginning, instantaneous velocity is the same thing as the derivative of the function. A soccer ball is kicked straight up. The height of the ball is defined by h of t equals 55t minus 16t squared, where time t is given in seconds and the height of the ball is given in feet. Find the expression for the instantaneous velocity. Okay, that's the same thing, of the ball at any point in time. So we're not doing a specific point. So as I mentioned, the instantaneous velocity v of t is equal to the derivative of the function. So that's my function of the height. So now I have to go find that derivative of this function right here. Okay, so v of t, 55t, t is to the first power, so 1 minus 1 is 0, so I'm just going to have 55. And then 2 times 16 is 32, and 2 minus 1 is t. So that is the instantaneous velocity. So the hardest part about this, y'all, is just remembering the vocab. So you got to remember what it's asking, because I know you know how to do it all. Okay, so another application of this derivative is the extreme value theorem. And basically, y'all, if you have a closed interval, I have taken this piece of the function right here from a to b. So I start here and I end there. If I have a closed piece of a function, then there has to be a minimum and maximum on that. Well, where do those occur? Those are called critical points, and they occur when the derivative is equal to 0 or it's undefined. So if I want to find the max or min of a function, this is a little bit easier way of doing it. We have a bungee jumper's height h in feet relative to the ground can be modeled by this function, h of t, on the interval from 0 to 6. So I have a closed interval where t is the time given in seconds. Find the maximum and minimum heights of the jumper. So as we said, easiest way now to find those max and min is to take the derivative of that. So the derivative of my 20t squared, well, 2 times 20 is 40t, because I lowered my exponent by 1, minus, well, t has an exponent of 1 times negative 160, and then the 330 is your constant, so that's going to go away. Now, up here, as you see right there, okay, we're going to set it equal to 0. So when I set it equal to 0, I'm going to add 160 to both sides and divide by 40, so I find out that t is 4. So to find the max or min, you got to use the points on the interval, and you use this critical point right here, and you're going to go find what the value of each of those is. So h of 0, notice that I have h here, y'all, and not h prime. So you take the derivative, you solve, set it equal to 0 and solve, and then you use the endpoints and whatever you get when you solved it and go plug those back into this function. So when I plug in 0, I'm going to get 330. When I plug in 4, I'm going to get 10. And when I plug in 6, I'm going to get 90. So what is the answer to my maximum and minimum height? Well, obviously my max height is 330 feet and my minimum height is 10 feet. Okay? So simple. All right, 2 more things we got to talk about. Product rule, and which is what I tried to start at the beginning instead of power rule. Okay? The product rule for derivatives. Okay, now look at this. This is the notation. It looks kind of scary, but it's not. This is notation for a derivative. And this is 2 functions that are getting multiplied together. Okay, and so what it is the first function times the derivative of the second function plus the second function times the derivative of the first function. Now that might be a lot to remember to write, so I actually write it like this because it's the same thing. So this says first times the derivative of the second plus the second times the derivative of the first. So here, and this is the nice thing about delta math, okay, y'all? This is all, well, look at this first one. H of x equals x to the 5th. There's my first function. There's my second function. So to find the derivative, it's the first times the derivative of the second. So how did I get 21x squared? 3 times 7 and then lowered the exponent. 2 times 5 and lowered the exponent. That doesn't have an x, so it's gone. So this is first times the derivative of the second plus the second times the derivative of the first. And in delta math, when you do the product rule, I think he only makes you do these 2 steps right here. So I think I just erased it. So here's another example, same kind of thing. And so you don't have to do all this work. So I want it there because at some point in your life you might have to. So it's good to see it. Okay. And the last one, we have the quotient rule for derivatives. Now, the quotient rule is a little bit harder to say. And I will be perfectly honest with you, that was a little bit messy for me and more than I could handle in high school. So I just ignored it and used only the product rule. I'm not recommending that, but I didn't know. Somebody since then has told me a nice little rule, so I'm going to share it with you. So I have d of this function dx. That's the derivative. There's my first one. There's my second one. I'm dividing because quotients answer to dividing. So if you label the top as a function called high and the bottom as a function called low, there's a cute little rule called, where it looks like this. It is low d high minus high d low over low squared. Okay. Now, I would sometimes get in trouble and mix these two things up. Is it high d low minus low d high, or is it low d high minus high d low? Well, they both start with low. So if you remember, low squared's on the bottom, low d high. So this means the bottom times the derivative of the top minus the top times the derivative of the bottom. That's just an easier way to say it, y'all. Okay? So look at these last two problems. And I'm trying to go down. All right. So what do I have here? I have j of x, and somehow I think that's an f, so I write f prime. My bad. 7x minus 10 over 12x plus 5. So it is a quotient. So I'm going to do low d high. My low is on the bottom. That's 12x plus 5. The derivative d high means the derivative of the top. Well, the derivative of the top, it only has a 7x. So that means the derivative of that is 7, because the derivative of 10 is 0. Remember, if it doesn't have an x in it, it goes away. Minus, so that was low d high minus high, 7x minus 10, d low, derivative of the bottom is 12, over low squared. Okay, now in delta math, you actually have to simplify this. And when you simplify, you have to just multiply out the top. So when I multiply out the top, it looks like this. It's still over the bottom. You do not have to do anything to the bottom, y'all. So when you multiply that out, you get that. My 84x's cancel. So I'm left with 35 plus 120. And I'm going to get, what's that, 155 over 12x plus 5 quantity squared. So that's how you enter it in delta math. All right, one more, last one, k of x. So k of x prime, it's a quotient, so I'm going to have a quotient. Low d high minus high d low, okay? And over low squared. Again, you have to multiply out that top. Do not multiply out the bottom. And when you simplify that, you will get 12x squared minus 24x squared is minus 12. So 24 minus 12x squared on the top, and 2x squared plus 4 quantity squared on the bottom. And that's all there is to derivatives. Thank you so much, and y'all have a great day.